Hi, I'm Tom, I talk about code, and welcome to another wonderful stream where we're going to be doing math APIs in Lua. We're just gonna get better at vectors, okay? We started it last stream, we're gonna carry it on. There's probably another stream after this where we do it. It is currently early in the morning here in Melbourne. My voice is a bit lower and meatier than usual, and we are gonna just smash out some maths. I don't think there's too much to say. So, let's jump across to a terminal. I need to do my thing. Make sure everything's nice and aligned. Oh, that's not right. I guess it is. I love DWM. I've hacked this to so that I can manually do my alignment stuff. Works really well. So rough plan for the day. Vector. We're gonna start with vector 2. I'm gonna show off what I did off camera. It wasn't much. I was hoping to have something good to show. But an important part of what I want to do today is to benchmark Lua performance versus C performance, just so we can kind of reason about this. Okay. I wanna know. And also, just before we get into things, I want to do a quick shout out. Before I forget, to More110 or More Morello, I guess, for a wonderful donation on Ko-Fi or Coffee. Huge. Really, really appreciate it. Really awesome. Makes me feel very loved, and that will definitely go back to supporting the show in a good way. So, with that said, let's get in and smash some code. What am I doing? Let's open up. So I've created a C source file for the math stuff. We will call these functions from Lua before we have, so if I go to Lua, math Lua, for example, adding two vectors together, it's not worth putting this addition into its own function, but I think the dot product, I think length, it is kind of worth wrapping it. For example, for now we're going to do math square root, but in the long run we may not, and we are definitely going to want to use things like dot and length in C code. So we want C implementations of this stuff, right? We want to be able to do this from C. And I've made an executive decision. All of our vectors are just dumb C arrays. It's just easy, right? There's no overhead. We access them, using array accesses. There's no .x, there's no .y. We could, in theory, try and do something fancy with a union, I guess, but I don't know. I just don't think there's any point. We could try and cast this to a different data type. Maybe you can cast, maybe you could cast a float 2 that has a length of 2 to maybe you could cast it to this type and it wouldn't be a problem. I don't know. I'm not fussed. I think this is fine and very readable. So we've got this stuff, and now I just need to bind this into Lua. So let's see what this looks like. And I'm getting to a point where I kind of feel like we're going to see this so much that maybe I need some kind of standard way of doing it. So maybe I say get buff, and we're just gonna take an index, right? And so it's gonna go. It's gonna do this in one line, because this is just a bit ugly. It's kind of annoying me. It's kind of bothering me. So do. Again, we're just going to assume that the Lua state parameter is called L, because we always call it L. We're kind of a weird thing to do in a macro, right? In one hand, all your variables should be taken in, but on the other hand, we're just going to make a good assumption. It's going to make this nice and simple. So I also think this actually has a good benefit of making error handling a lot easier, because at the moment, we don't really check that what we get gives us what we want other than this null check here. I guess this null check is the only place it really matters, because Lua is very tolerant with you doing things wrong, right? If you ask for something that doesn't exist, it's just going to give you a nil. But if this table is nil, I don't know what happens. I think we might crash. So there might be a little bit more error handling that we need to do. And so it'd be nice to be able to do that in one place. So anyway, push string pointer, get it from the table that we've passed in as our index. I guess is no, I should be fine. And then we're gonna, I guess we need to give it a name to bind to. So we're gonna call it 2 equals Lua 2 user data L -1. This is fixed. Hold on, but we need to not put that in a do block because we want this to leak out of scope. That should be okay, right? And then buffer null check 2 MSG Okay, this is magic. This is magic. And then the last thing we're going to have here, we're going to cast 0 to void, because that always means, because we want to use this like it's a real function, right? So we're going to come up here and we're going to say get buff 1, buff 1, copy vec. So we can replace this line with this, right? This is going to expand to exactly the same thing, or at least it should. And the reason we want to have this at the end, right? We could just omit the semicolon from here, but if we add things, if we change things, it might be a little bit messy. I like to have a really clear, this is the end of the macro, and this is the thing that the semicolon's going to go on to make sure it's okay, right? Because if we don't have this, and we just end this line here with this semicolon, we're going to get a syntax error because we have 2 semicolons in a row when this gets expanded. So let's start by doing this and just see if it works. Let's just see if this makes sense. Buff2. I need to start Docker as well. I love a good early morning show, right? I'm fresh, got lots of energy. Feeling good, I'm feeling good. Alright, so let's see if we can build. And we can't. Buff2 is undeclared. Okay, hold on. That is because, very, very simply, I defined this after it was used. That makes sense. So let's have, look, I don't want to build up too many gross macros for this, but also, sometimes it just makes sense, and that works. Love it. So yeah, let's collapse some of our other code with this, right? So add, we're just going to replace it with get buff. It's going to make these functions simpler. I added a subtract as well, so let's say get buff 1 buff, what did I say? What order was, yeah, 1 buff 1 sub vec. Get buff 2 sub vec. And look, it's a bit messy, but this is nicer. If we go to line 48, we put this in. Yeah, I'm just worried this file is going to get very messy very quickly. Okay, so let's go Lua dot, let's get Lua length vec2. Now we have a function for this. In ps2math.c, p2m vec2 length. So we're going to go get buff 1 length vec. What do we want? We want to just call p2m. Now this is an interesting one as well, because doesn't have a vector result. This actually just pushes something to the Lua return stack, which we're actually not doing yet, right? So p2m vec2 length buff 1. We're not checking it's the right size or anything. It's okay. We're flying loose and fast here. I guess that's okay, right? I guess that's okay. So the result, and then we just need to push it. Lua push number L result. Too good. And then we have to return 1. We have to tell Lua that we returned something on the stack. We're going to do a similar thing. Lua dot vec2. I feel like I'm already getting great mileage from this getBuff function. Float vec2 dot Lua push number. And we return 1. Awesome. So let's bind these things in and see where we go. Push C function Lua length vec2. len vec2. We'll just give it a nice short name because we'll wrap these in our library anyway. Push C function in our Lua code anyway. These get wrapped, so we'll have a look at that in a sec. Lua.vec2. Wait, hold on. I went on autopilot. We need a second vector to do the dot product. Funnily enough. I love it. Awesome. And we've actually reflected that in our function signature. Good, 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 good. And then we also have subtract, where we well, you know, we have an add, we have a subtract. That one checks out. Add sub, and we can just do a find and replace like that. Beautiful. Okay, this is looking good. This is looking good. This is looking good. So I can build this. It's going to yell at me about a few things because I don't actually compile or include the PlayStation 2 math header. I don't actually have a PlayStation 2 math header, so let's start with that. If and def ps2 math h. Awesome. Actually, let's just grab this whole source file and then we'll clean it up in here. If you want to make a quick header file, I highly recommend, just copying and pasting your source and cleaning up the function bodies very quickly. That's good. That's good. And you know, this is a very simple, signatures. Nothing to really consider here. So let's include this here as well, just for good measure. Include ps2 math.h, and we have to put this after our angle bracketed thing, otherwise our linter yells at us, as we learnt last stream. Mathlua.c. So we want to include ps2 math.h, and then we also need to add it to our make file. ps2 math.o. Awesome. So now when I build, this should work. And it doesn't quite work. It doesn't quite work. Oh, hold on. Yeah. Whoa. I mixed my Lua with my C. Is it f squirt? I can never remember what the function's called in C. So we're gonna have a quick Google. It's Googling time. C dlib squirt. Is there not a floating point version of this? It's just called squirt. Squirt F. There's a Microsoft version of this. I don't know if there's a C standard library version of this. Well, let's just try it, right? Let's just squirt F. And yeah, I guess that does feel more logical to have the F afterwards. Control reaches end of non-void function, defined but not used. That's okay. That's because I'm guessing we've got a bracket we're not closing somewhere. Also, anyone look over my linear algebra and see if I made a mistake, because, you know, that does happen. Surely I've missed a bracket somewhere. I was playing around with this quite late at night. This looks like a valid... What am I missing? Let's actually read that error more carefully. Expected declaration or statement at end of input. Line 25. Control reaches end of non-void function at top level. Top level. Okay, so vec3 length. So it says vec3 length never... Oh. How did that... What's this doing here? How did this happen? Okay. There we go. So we run this. It doesn't explode. This is good. This is good. Math. Let's jump into our math example. Let's change this so we only do it once as well. I think that would be good. Local do once. Well, done, I guess, equals false. If not done, then do this stuff. Done equals true, and cool. So, didn't need to build that. I could have just run it. This is the whole point of the scripting language, right? We do this vector stuff and we get a result. Awesome. So we add this stuff. Let's go v1 let's go local L equals v1 length. Well, let's think here, because we use we use this big global table to get the constructors, but then it should all just be instance methods, right? So we haven't defined these functions yet. So let's get the length, and let's go local L equals v1 dot v2. I guess let's call it d. Let's go log dot info v len equals v1 v1. Let's go L and then dot equals d. Let's just do this for now. Let's do this for now. And then if we go into ps2 math.lua, we just need to actually define these things. So function types, we add it to the meta table. We're going to add a length, which takes no arguments, and it's just going to call m dot length vec2 self dot buff. I think that makes sense, right? Math lua. We got it len vec2. We're keeping things lean here. Len vec2. I love it. I love it. And then we just return this, right? This is a really dumb wrapper. And I don't know if this kind of wrapper really incurs a cost. If it incurs much of a cost in Lua. And this is one of the things I kind of want to benchmark to find out. So let's say m dot vec2 self dot buff other dot buff. So the idea is that we're passing in the actual underlying buffer to these raw functions, but we're providing this higher level interface where we don't have to worry about the fact that, you know, these vectors are actually just backed by a really dumb C array. It's a simple idea, and I think it's working well for us so far. We also want to we also want this sub vec2. Love it. Love it. Awesome. So let's see if this runs now. If it doesn't, if we have a syntax error, it's going to yell at us. It has a length, it has a dot product. Add result. Okay, so this add result changed. I don't know if you noticed that. Because we didn't change this to subtract. We just redefined addition. And that's not good. As a general rule, you probably don't want to redefine addition in your day-to-day life very often. Length. Is this right? This seems right. This feels like a reasonable length for a vector that has these components. And the dot product. The dot product, right? So we have... So what do our vectors look like? 5, 4, and 7, 7. 5, 4, and 7, 7. Yeah, okay. They're pretty close to each other. So let's build a perpendicular. Wait, did I? Wait, hold on. Yeah, okay, hold on. So what do you do? If this vector's 12, 11, you do like, what is it? Negative 11, 12? Right? But then I actually need to like dot it. And then I should say so log dot info 0 equals v1 dot perp. If I run this, so it should be 0, right? And it is. Cool. That gives me confidence that our dot product's correct. At least when it comes to finding perpendiculars, we have now verified that our dot product is correct. So if we think about this, we've done this. Oh, we haven't done rotate. 2D rotate is actually very important. So rotate 2D vector. This is really simple to do. Sure. Let's just find rotation matrix. Like in theory, we're doing this with a matrix, but in practice, yeah. Point xy defines a vector has a length L. Rotate it anti-clockwise around the origin by b degrees. This, right? So there is this is like expanding out a matrix, and you see this all the time. So let me just grab this to my second monitor. Not like that. not like that either. Hold on. There we go. Cool, so ps2 math.c, and this is something that I think we might try. I don't know, maybe this one actually will never be sped up by assembly because we have to do the cos and sine. But again, maybe, like, the sky's the limit. I can't remember what kind of instructions we have for doing floating point math. Surely not a cos and a sine. But again, you know, we could do like a lookup table or something if we wanted this to be really quick. Really quick but less accurate. P2M, vec2, rotate. And this is something we're only going to have for vector 2, right? For vector 3, we're just going to rely on matrix operations. So we're going to have a vector 2, and we're going to have a float theta. I like to call this theta because that's just always, you know, if you like do math and you're doing your like unit circle stuff and you have degrees from the origin, you always just call this theta. At least where I did, you know, at least where I learned, right? At least where I went to school. So I don't know, I always like to call the variable for rotation theta. That's just kind of baked into me. So we return, not return, sorry, we v2 0 equals, and we do this in place. Again, we're gonna have options in our Lua API for doing it in place or not, but here we do it in place. Cos, I think there's a cos f, right? I think there's a cos f. Theta times v2 0 minus sine f theta times v2 0, v2 1, sorry. So cos of the angle times cos of the angle times the x part minus sine of the angle times the y part, and then the y is, you do like the opposite bit, right? So the sine of theta times the x part minus, no, plus, sorry, cos of theta times the y part. And then we return nothing. This actually does not return. I'm just gonna line that up. I think that looks a bit nicer. Cool. So we've got our rotate, and let's jump into our Lua binding and see how we go. Math Lua, static int Lua, rotate vec2. Cool. So we're gonna get the buffer as our first argument. And then we need to grab a floating point number as our second argument. So float Lua 2 number. Grab the second argument off of the stack as just like a number with a decimal part. And then we say P2M vec2 rotate. Sorry, what am I? We rotate it by an angle, and we return nothing on the stack. We leave nothing on the return stack. So, that's looking good. That's looking good. Rotate... yeah. Yeah, cool. I can't... you gotta bear with me, guys. It's early in the morning. It's hard to type, okay? It's hard to type. Lua push C function L Lua rotate vec2, and we're gonna call this. We're gonna call this rotate vec2, I guess. But what's gonna be important now is when we come into PS2 Math Lua, how we expose this. So function. So I guess we'll call it rotate. M dot rotate vec2 self dot buff, then the angle. But then we also want a version of this that gives us back a new vector that is rotated, right? So again, I guess you could call it rotated, but that's a little bit too close to rotate. Copy, I guess we could say copy rotate, right? That kind of tells us, or new rotate, or I think copy rotate kind of gets the job done, right? Copy rotate. Get a copy of this vector that is rotated. So we go local n equals is this? Yeah, so we make a new vector 2. And for now, this does a really gross call to our resource manager alloc. We don't have a way of building a buffer on the Lua heap yet, but that's okay. We're getting there. M.copy. Well, I guess let's just rely on the higher level stuff. Let's go self. Let's go local n equals self. Copy. Wait. From. Copy. Hold on. This isn't quite right, is it? This very much isn't quite right. Because this is a metadata method. How am I calling this? Hold on. E.g. copy. I'm not calling it yet. Okay, well that makes sense. This is weird, right? Because this is a method on an existing vector 2, yet we still create a new vector 2. So what we actually want to say is this is like when we want to copy the fields of one vector to another. Yeah, sure. And then maybe we make a function like and right, so rather than doing weird stuff like in an actual method on a vector 2, we have this static variable where we create a vector 2 from another vector 2. We make a vector 2, and then we do the copy, and then we return it. That's better. And so none of these should return anything, right? None of these should return anything. These are really transparent views into this other stuff. They're just wrapped up in this objecty, Lua-y, flavored wrapper. So this now becomes types.vec2 from self. So we make a copy of ourself, and then we rotate the copy by some amount, and then we return the new value. Sure. So we can do that down here, right? We can say v1 copy rotate, and we'll rotate it by 1 radian from the origin. So that's like, you know, that's what, a third of half a circle. So it's like it should be, we should be going from here to here ish, I guess, right? Okay, well, let's see what happens. Let's just run it. Let's go. You know what else would actually be good? It would be good to be able to convert a vector to a string. Types.vec2empty. Now we can actually do this Lua meta table stringify. Stringify. String. There's something for this, I'm pretty sure. Index. I'm pretty sure there's a meta table thing. Binding operator, yeah. And actually, you know, in hindsight, we probably should be doing this as well, right? But we'll think about it. Cool. It's really cool you can override cool. I forget that. ToString. Change the behavior of the print statement. Does this just change the behavior of the print statement, or can we use this other places as well? ToString equals this thing. Okay. So let's do that. So the index is this. ToString equals. But how do we Lua when is ToString called? What I don't understand is how we actually stringify things. Like, when is it used? Just so I can understand them. That's not what I want. How can I override the ToString metatable? Currently print blah, blah, blah. ToString entry must exist in the metatable for every instance you return. Set meta table. Okay. In conclusion, I don't really know. Lua API reference. I guess let's just search this for string as well, right? That kind of makes sense. Reference manual, because this has a list of all functions. And there is indeed a toString. Okay. So literally more simple than I thought. Cool. We will empty.string. And so I'm guessing this just takes like a self or something. Or even we can make this like an implicit self. This is kind of weird, right? Because this, I guess, is kind of called as a method. We're like passing it through as a function, but then we're defining it like a method. I think this will work. So we want to return self.x, self.y. We don't even need to. Cool. So let's see what happens now if I come in. Well, let's see what happens if I run this, if I hit some weird syntax error. And I do attempt to call new value rotate vec2. Is that because I didn't build? Is that because I didn't define this? No, rotate vec2. Did I not build? I didn't build. p2m vec2 rotate. Implicit declaration of function. Did I mean p2m row? Did I mean? Okay, where's the difference here? v2. v2. I missed out a letter C. Vet2, yeah, cool. You know, sometimes you just forget to build, and that's okay. So this is good. So now instead of printing it out like this, let's go. Well, what happens if I just go v1 now? Now that it has this, will it know how to implicitly convert itself to a string? No. To string. But now we should get something nicer, right? Yeah, we don't need to do the manual janky stuff every single time we want to print out a vector. I like that. I like that a lot. All right, so what can we do with this? I guess it'd be good to have some kind of example, right? Where we have like a cube, or a square, sorry. And he maybe has like an angle. So he like moves in a constant direction set by some angle variable, and over time that angle drifts and he's gonna like move around a bit. I guess we could control that from the controller, but that's not really the key. I guess left will like increase his angle and right will decrease his angle, and he'll just slowly cruise along, and we can see what happens when we try and rotate a vector. So what do we need? We also need to be able to scale a vector, right? Because he's going to have some velocity. So he's going to have a unit vector that represents forward, right? So this is going to be 1, 0. He's going to have an angle that represents where he's going, and he's going to have a velocity. And we're going to combine these three things into a nice bit of movement logic. So I guess the first thing you do in a frame, right? You get a copy rotated vector from his forward direction, and you rotate it by theta. You scale this by v, and then you go, right? You just move that distance. And there are a few things to consider, like as we rotate this, if it's greater than 2 pi, well, then we want to like subtract 2 pi from it, aka tau, the beta circle constant. Come at me, Cool. Let's do that. So we'll do this math stuff once on startup and just like see if stuff works. And now, just for the fun of it, let's go into our rectangle example and just like copy our, so it's not hard to draw a rectangle with this API. We'll draw a red rectangle again because I like that. We'll make him a little bit smaller. Let's go. So we go local rx. Well, hold on. Let's make position a vector. Position's gonna be a vector. Oh, and this is gonna thrash. This is gonna thrash the garbage collector. Okay, we're gonna make a position vector. We're going to put him at 100, 100. We're going to make a angle vector. This is going to be 0. We're going to make a forward vector. This is going to be our 1, 0. This is going to be what he considers forward, right? So when my angle is 0, which direction do I go in? And then we're also going to kind of just cheekily go... we're going to make an empty vector 2 to use for work so that we don't thrash the heap too much while we're still in this world of not actually having Lua allocated buffers yet. So we've got a rectangle and we're going to draw him, instead of 2020, we're going to draw him at pos.x and pos.y. So let's do this first. Let's see what happens. That's cool. That's a much nicer way to define a position rather than, like, you know, just having to track 2 variables or something like I was before. Okay, so let's make a function to step this. We'll call it step player, even though it's not really a player. If pad.left, I can't remember how my pad API works. What am I? Yeah, pad. If pad.held pad.left, then pad.held pad.left. There we go. I got there in the end. If we're holding the left button, then angle equals angle minus local RV. So we're going to have a rotation velocity, and this is going to be like 0.1 radians. So let's go 0.01 radians, local V, and we're also going to have a velocity, which is going to be like 2.4 pixels per second. Cool. Angle minus RV, else if pad.held pad.right, then angle equals angle plus RV, end. So we move the angle, right? Either left, which is going to... I guess left is positive if we're going anti-clockwise and right is negative. And then if angle is greater than tau, angle equals angle minus tau. And if angle is less than 0, then angle equals angle plus tau. We would just want to keep this in a nice range. And in this case, we're also going to find local tau equals... Is there a math.pi? There must be, right? Lua math.pi. There must be a pi constant defined. Pi. Math.pi. I think we have to require math, though. No, we don't, right? That just comes batteries included. Awesome. So, this should be good. Just make sure, like, you know, we can actually, our angle, like, radians just wrap around. It doesn't matter, but just for the sake of our number and not eventually accumulating floating point errors, we're going to do this. And then we also need this cute little end, because Lua's fun. And then we're going to say, what are we going to say? Math. So I actually want to use the underlying... Okay, we'll do this the dumb way first, then we'll make it better. Local... So our direction is going to be a forward vector, rotated, but then also a copy of it by our angle. Then we have to multiply it, then we have to scale it. And that's going to be... So, dear scale by our velocity. That's okay. We need to define this as well. And then we just say pos add. I guess say pos add. Yeah, pos add our direction, right? And that's it. It's that simple. It's that simple. We just need to add the scale function. So let's go ps2 math.c. We don't need to do it here actually. Maybe we should, because this is something that we maybe can actually speed up with assembly. So p2m vec2 scale. We've got our vector and we've got a scalar. v0 times equals s, v1 times equals s. Easy. We need to add this to our header. And then we need to add a Lua binding for this. Math Lua. Oh man, isn't this riveting? I promise this is going to get more exciting soon. Once I've got this done, we're going to fly through some awesome 3D math stuff. It's going to be great. It's going to be so much better. Scale vec2 L -2. Cool, so scale vec2. We need to get a buffer. We need to grab the scalar. And then we just call p2m vec2 scale buff1 scalar. And we return 0 because there's nothing left on the Lua stack. So I should be able to build this. I should be able to run this. Is he moving? I think he might be moving. I think he's moving very, very slowly. Okay, we're going to crank up the speed on this bad boy. We're going to crank up the speed. And that's why it's good to define this in a... I mean, you know, obviously don't do it like that. Oh, wait, hold on. Of course he's not moving. We're not calling step player. Never mind. Hilarious. Hilarious. And now it actually blows up. That's cool. Copy rotated is not a value. I've also made another mistake. We'll get to that in a second. Nil value copy rotated. I think that's because it's just called copy rotate. And we're gonna run this again, and my hypothesis is we're gonna see another error. We're gonna see an error calling scale because I don't think I've actually defined it in Lua math, and that's absolutely what we see. So if we go math, ps2 math.lua, we need to actually build this thing function in the meta table scale s m.scale vec2 self.buff by the scalar. Perfect. And we scale in place. Now we run. Everything works. Whoa. Yep, there he goes. Okay. I take back that speed needed to be cranked up. This speed needs to be cranked down. We're going to put this at like 0.8 pixels per frame, right? Which actually adds up to quite a lot. Okay, so we're pressing the left key. We're pressing the left key and nothing's happening. Pad held, pad lock. This should be the right API. So what if I go... Let's just print something out if we're holding the left key. Let's see if I have configured... Okay, that would explain it. I need to go into my pad config. Gamepad settings. For some reason ESDF are my keys. That's good. So what if I go... Whoop. That looked like it did something. Let's run this again. And he's rotating. He's not quite rotating correctly, but he is rotating. Copy rotate. Okay. Okay, there's a few things. There's a whole chain of things to consider here, right? There's a whole chain of things to consider. So for copy rotate. Okay. So we're not blowing. The only thing that is modified here is the actual position. That's good. That's good, right? And also, if you're wondering why I haven't done these with like proper meta tables yet, because we can do this, we can say pos plus dir. It's because these have to return things. So if I, for example, were to jump over to ps2 math.lua, let's say, yeah, so like in the meta table, I would have to do it like this. So v2 index, toString, I would have to go add equals function, I guess it's function a, b, right? And it would be, you would have to do, hold on, bear with me a sec here. We'd have to like grab types vec2, we'd have to like make a new vector, we'd have to say n, and then n add b, right? We'd have to like do it like this. And we could do this, but it's like cumbersome to do it for everything. So I guess I'll keep it now that I've got it. I guess this will still run fine. Okay, so let's go back into our example. Sorry, I just got a little bit sidetracked with an idea there. But yeah, so I mean, I could go pos equals pos plus dir, for example. And that would blow up. Sure. I think I didn't return anything, right? Ooh. Interesting thought here. Morello, thank you very much for stopping by. Does the input variable in C need to be set to volatile so the compiler doesn't do weird optimizations? The input variable, like the like in which call? Do you mean the scale, or like the rotate, or even the buffer? It potentially. But in this case, I think the compiler should see that it's used, right? The compiler should see that it's okay. There are a few places volatile is important when you're doing like DMA stuff, when you're dealing with weird registers that have weird memory addresses that are mapped to registers that have side effects and stuff. In this case, I don't think it will make a difference. God, this is still quite fast. Okay, so I can... Oh no, hold on, what am I doing? So if I rotate this to the right point, he kind of stops. Maybe? Or maybe he just... This does seem like it's kind of working, right? He just rotates very, very slowly. What if I rotate a bit speedier? If I make him a bit like... Oh. What if I give him an RV of 1, right? What if we really fly here? Yeah, something weird going on. Thank you so much. Doing some Drift King action now. Prof Elements. Glad you're finally able to stop by and catch a stream. Thank you. Alright. So I think the only reasonable thing to do here is to just say log info. Let's just log our direction vector, right? Oh, I guess the other thing that I need to think about. So, I'm blowing up my C heap. Every frame I'm going to be allocating a new vector. So I'm actually going to just change how this works a little bit for a sec. I'm going to use this work vector rather than creating something new, and I'm going to do it directly. I'm going to say m copy. Hold on. Copy vec2. We're going to copy to work from dir. Did I call it work or work? I called it work. I called it work with an O. No cutting corners here. No cutting corners. Copy vec2 work dir, and then we're gonna say work. Work forward, and then we say work rotate. Right. So we're reusing this one variable, this one vector that we create once. It's just better. Angle, and then we're gonna scale, and then we're gonna add. So let's see what this looks like. Attempt to call in a value copy vec2. Now, I just don't believe... Oh, hold on. Yeah, that's because this is actually... I aliased that name. What do I call it? Math clib. Cool. And got null buffer for copy vec. Null buffer for copy vec. Forward work. Because oh yeah, we're including m as this. Interesting. That's the copy vec2 work forward work. Why is work nil after this? If I go back to PS2 Math Lure and look at how I've defined copy, how have I done it? Copy vec2 self-top. That's right. .buff. I need to explicitly say, and this is why I'm not calling these functions directly, because it doesn't hide the fact from me that the vectors are just buffers under the hood. Attempt to index a null value global scale. Sure, that was just me being silly. Okay, so why? Oh yeah. Wait, why is this? Oh my god. So if angle is 0 and forward is 1 0, why is my out? Oh. Okay, hold on. Have a look at this. Right. So, forward vector. Okay, it is we're going this way, right? 1, 0. And our angle is 0. And we multiply it by 0.4. So this should be 0.40, and instead of 0.4, 0.4. So that tells me that if I look at my math definition for the scale function, I'm probably doing something dumb with the x element, right? Probably. ps2 math.c scale. And I'm not. Forward. See, forward never changes, right? Forward never changes. Let's go toString forward. That's fine. So log.info toString. Let's just see what happens after we rotate it by an angle of 0, right? Because that's going to be very telling as well. We end up with the wrong vector. That's good though, right? This tells us that it is in fact rotate that's wrong. So let's keep this. Let's go back to ps2 math. Let's look at our rotate again. Let's put this under a fine-tooth comb. So we've got some angle. And this should be, and this looks right, right? Cos theta times x minus sine theta times y. Sine theta times x plus cos theta times y. And we're setting this to x and y. This feels correct. This feels correct. This feels correct. x2 cos theta times x. Cos theta times x minus sine theta times y. xy. Sine theta times x plus cos theta times y. Does anyone see what's wrong with this rotate? And this isn't like a trick question. I don't see what's wrong with this rotate. I guess another thing I can do, I can go in here to where we rotate, and I can log it here, right? So I can go info rotate thing. Let's go buff. Let's go f by. We'll go buff 1 0 buff 1 1 angle, and then we'll go rotated thing. Is there something? There's got to be something really. Sorry, hold on. I've just got to include log.h. There's got to be something really, really dumb that I've done. There's got to be. There always is with this. Rotate this by this, and we get this. Okay, hold on. Let's think about this. Let's think about this. Okay, because this is actually really easy to do in our head. So, where are we? ps2 math.c. Okay. So x is 1. Theta is 0. So cos 0 minus sine 0, cos of 0. Let's draw it out. Let's draw it out, right? We've got our unit circle. We've got our unit circle. Okay, cos of 0 is 1. Sine of 0 is 0. So this is 1. And then sine of 0 is freaking 0. And cos of 0 is 1. This is wrong. Wait, what's going on? What have I done? What have I done? Why? Because if the angle's 0, then these are both. That's not right. Wait. That's not right. What am I missing here? I'm missing something really obvious here, surely. Surely. What have I... Because if theta's 0... The y component has to be 0, right? It has to be 0. X sine. Oh, hold on, I'm multiplying in the wrong place. Oh no. Okay, hold on. So you can see why I did this, right? Look at this. Look at the way this is written. This looks like it's cos of theta times x. I knew this. It shouldn't have taken me this long to realize this. I knew this. I've done this before. So x times this, right? X times cos theta. Not, you don't multiply inside the thing. What am I doing? What am I bloody doing? Y times v21 v21 times... Oh, that's insane. Now look. Isn't this weird? Isn't it weird how this now looks like the right answer? Let's make our logging a little bit less verbose, because I think we're going to be good now. We need to up our rotate value. Or maybe not. Maybe this is okay. Let's see how we go. I think this printing is actually slowing us down a little. So let's see what happens. Oh, hold on, I can keep that one. And it seems like the Y component isn't being calculated correctly, because it feels like our speed changed a little as we did that. Maybe? Maybe. God, why does this always go so badly for me? I can't believe it. Let's get some of our printing back. Oh no, yeah, we're just not rotating at all now. That's not what I wanted. Let's build it. Let's run it. And let's see what happens if I'm pressing the button. I'm pressing the button, right? Why is my angle not changing? Why is my angle always 0? Have I... Hello? Surely I've like... What? Why is my angle always 0? Why is my angle always 0? What have I done? RV... Well, what if I just change angle to like math.pi onto... What happens then? That's not, yeah. That's not right. Rotate thing by this. Rotated thing. This is why you use already made math libs, yeah. Yeah. I like, you'd be like, okay, I'm gonna rotate a 2D vector. How hard can this be? And then you sit there looking like a fool for 40 minutes. But, look, what I think is good here is that you can actually see, like, these APIs are pretty nice. These APIs are pretty nice. And if I actually have done my... Let's just do one more cool thing and then I'm probably gonna head off. Let's go back and look at this, right? So this didn't work for some reason, right? What if I go pos equals pos plus work? Did this work? I mean, this did actually work in the end, right? And that's pretty cool. So we've got to fix our rotate. I am gonna probably just play around with this. Actually, let me try one thing, right? If I do this and I go left, yeah, so it's the Y component of my rotate that's broken, and actually I can probably... V1 equals... okay, it looks fine. It looks good. That's what we expect it to look like. X sine theta plus Y cos theta. Okay, I've got some more thinking to do. With that said, I'm going to have to go. I've got to start working a bit. I've got to make breakfast and stuff. Hope everyone has had a lovely stream. More wonderful maths. Oh boy, once I get this stuff right, it's going to be so good. It's going to be so much easier. For everyone watching on YouTube, thank you very much for tuning in.